I'm Sam Turner, and I'm going to be explaining a problem about the break-even point. Now, here's the problem here. We're given a lot of information, but I've gone ahead and narrowed down what's most important here. So what we have is it's just one company, and they have two options here. Option A and option B. First option is to use machine A. And we're given that machine A has a $4 manufacturing cost per unit. It's important to pay attention to that, those units there, cost per unit. We'll come back to that. And we're also given that there's a fixed cost of $3,000 for tools. Now, the second option is to use machine B, which has a 50 cents or half dollar manufacturing cost per unit, once again, and an initial cost of $45,000. The last piece of information we're given is that there's an anticipated volume of 7,000 annual units, meaning in 1 year, 7,000 units will be produced. And then the question, which I've circled, is what is the break-even point in years most nearly? Now the break-even point is when each option, machine A and machine B, will both have an equal total cost. So what we can do is we can set up an equality for machine A and machine B. So we'll do that right here. Now putting machine A in black, on the left side, and we'll put machine B in blue on the right side. And I'm going to go ahead and define what we were looking for. Because we're looking for the break-even point in years, we can define that variable as T in years. And this is our goal, to find this. So let's start with machine A. We have $4 manufacturing cost per unit. So we put that $4 here. And because it's per unit, we have to multiply that by 7,000 annual units. So that translates to 7,000 units per year. And so we've got dollars, units per year. So we still need to multiply this by time. Oh, we've already given time in red, so we're just going to keep that so we know what we're looking for in the end. And to add to this, we have to add the initial fixed cost for tools, which is $3,000. That's plus, that's T. $3,000. And we want the units of each of these quantities to be the same. So we have dollars here, and we have dollars units per year of years. So we actually need to put dollars per unit here. And now these two quantities have the same units. Now we'll move on to machine B. It's equality, so we put an equal sign there. We could actually do something pretty cool here. Make that half black, half blue, just for fun. And we do the same as we did before, but for machine B, we have the 50 cents dollars, not 50 cents dollars, 50 cents, or $0.5 per unit. And again, we multiply that by 7,000 units per year. Because both options have the same production. And again, we add the fixed cost, for this time fixed cost of machine B, which is an initial cost of $45,000. Actually, we first should add, we have to multiply this by T, as we did before. You thought I was going to forget, but I didn't. $45,000. Again, the distinction between T and plus. So now all that's left to do is separate quantities. Because these two quantities have a T, these two quantities do not have T. We'll put two quantities that do not have T, we'll put those on the right side. So we'll go with $45,000 minus $3,000, because we're bringing this to the left side, so you subtract it from both sides. That comes out to $42,000. And next we have to put all the terms that have T on the left side. So it means we subtract both sides, we subtract this quantity with 50 cents per unit times 7,000 units times T. So that takes it away from this side, brings it to this side, and we have 7,000 units per year. Because this is 7,000 units in both these, we can just distribute. We have $4 per unit minus 0.5 per unit. And of course, in front we have T. And again, that's what we're looking for. So all that's left to do is divide both sides of the equation by this quantity, so that T is by itself. So T equals, we have the 42,000, 42,000 divided by the 7,000 units per year. And that's multiplied by $4 per unit minus $0.5 per unit, which is of course $3.50 per unit. Now all we have here is simple division. Go through the first stages, we can just cancel out the 1,000. 42 divided by 7 is 6. Then we have 6 over 350, which that is T equals approximately 1.7. We gotta make sure our units are correct. So we got $1 here. We have $1 here, so we cancel those out. Then we have units here, Then we have 1 over here, we'll bring that to the top. And this 1.7 is in years. That's our answer. Now we look back to the problem, hopefully that is an answer over there. And what do you know? Answer B, 1.7 years. And that's the answer. It's an example of the problem, break-even point.